I want to share a simple story, and it's about a building in New York City, a big high-rise. And the tenants in this high-rise were very upset about the wait times during peak hours for the elevators. And it got to the point where they were even threatening to break their leases. And so management sent in the engineers to the building, and they sat around and they thought about whether or not they could increase the speed of the ascension of the elevators in order to reduce that wait time. They looked at whether or not they might build a new elevator, install a new elevator. But then one of the engineers called his friend, who was a professor of philosophy, and explained the problem to him. And the professor paused and said, "You don't have an elevator problem. You have a people problem. They're bored while they're waiting." So the engineer thought about this, and they went back to the drawing table, and they decided to install some mirrors around all of the waiting areas for the elevators. And sure enough, the complaints stopped immediately, and the tenants were happy. So, the thought I want to leave with you today is, are you asking the right questions? Are you solving the right problems? And now I want to introduce you to Professor Gregory LeBlanc, who is my former professor. He is a thought leader in data analytics and in digital transformations and in much more. And he's also a man who has helped me learn how to ask the right questions. وأخيراً أريد أن أرحب بكم باللغة العربية. لقد شرفتونا بوجودكم هنا في هذا المؤتمر ونورت دبي. So please grab your lunch quickly. Greg is going to be speaking here. So if you can grab your lunch and come back here in about 15 minutes, I promise you it is going to be a treat, okay? Thank you very much. And so what that means is that Walmart rarely has any stockouts and they rarely have any surplus inventory. Okay, so it's just in time, right? Just in time delivery throughout this retail system. Okay, now this is going to require a large amount of information, a lot of data capture, and a large amount of analytics, you know, because they can actually track the location of all these items in real time. Okay, there's another company called UPS. All right, what kind of company is UPS? Logistics company, all right, yeah, you can say that. But I'm going to try and argue that they are, in fact, a technology company, right? So you thought Amazon and Google and Facebook were the only technology companies out there. These guys are a technology company. Okay, just to give you an example, they spend over $1 billion a year on software. They're a software company. What do they do with all this software? Well, here's an example of a problem that a company like UPS has to solve every single day, everywhere in the world. You've got a driver, and he's got 120 packages to deliver. How many different ways are there to deliver 120 packages? Oh, we're asking this driver, sitting in a truck, to decide on the route that he's going to take with his truck. So he's got to think about it. How many different ways are there to deliver 120 packages? No, not 120. There's more. 1,000? 10,000? Million? You want to guess? You're a speaker. You're exempt. Anybody? Million? Billion? 10 billion? Well, here's how many ways there are to deliver 120 packages. So this is our Earth, and this is how many seconds old the Earth is. It's actually not quite updated, but that's how old the Earth is in seconds. This is how many ways there are to deliver 120 packages. Okay? That's a lot more than you thought, right? Now we're asking some individual to solve for which of these many ways is the shortest. Obviously, that's not something that a person can do. So how do we solve this? With software, right? That's why UPS is a software company, okay?
Now, in addition to being a software company, they're also a technology company in the hardware space. So what they do is they use telematics. So their trucks are connected at all times, right, to the cloud. On the truck, they have sensors throughout, on the engines, right, in the backs of the truck, on the wheels, everywhere in the truck. And so at all times, they know where the trucks are, and they know what the drivers are doing. So they know whether the drivers are backing up, they know whether the drivers are idling, they know if they're using their seatbelts. They can actually see that the drivers are using their seatbelts or not. How do they do this? With sensors, right? And those sensors convey the information into the cloud, and they can be tracked in real time, and you can do analytics on the back end, okay? So with analytics, you can create dramatic cost reductions. They know where the packages are from the moment they're picked up until the moment they're distributed. They use this to optimize distribution through the warehouses. They optimize even the packing of the boxes on the truck so that the person doesn't have to bend over to pick up the heavy packages, because they actually know the probability of a back injury as a result of the different ways of packing the truck. Okay, now, why do they do this? If it costs them $3 million to create this software called Orion, how long do you think it took for them to make that $3 billion back? Less than 2 years. Less than 2 years. Because if you can figure out how to reduce driving time by 15%, labor costs by 15%, truck wear and tear by 15%, fuel consumption by 15%, and get the packages delivered 15% earlier across the board, you're going to save a lot of money. Okay, this is all because of analytics. It's also because of what we call the Internet of Things, right? Everything is connected. So this estimate says that we're all going to have more than 6.5 items connected per person in the world. I don't know about you, but I've already blown past through this. I have more than 6.5 items connected to the internet, including things like a smart meter or a Fitbit or an iPhone. Okay? Now, where I think things are interesting, because you think of Internet of Things, you're typically thinking about Fitbits and phones and your car and so forth. Where I think it's really exciting is in the industrial space. Right? So in the industrial space, what we're going to have are connected everything, connected factories, right? Connected components, connected infrastructure. And so we'll talk a little bit about this, but I want to give you an example of how Internet of Things is completely transforming the industrial space. So General Electric's been in the news a lot lately, okay? What kind of company is General Electric? Okay, so now you guys have got it, right? You got the answer, you know, right? Every company now is a technology company, and so in the back of your head you should be thinking, hey, is my company a technology company? So here's a story about how General Electric got transformed in the last 12 years. They sell a lot of products. They sell turbines, they sell drill bits, they sell MRIs, they sell locomotives, and of course they sell aircraft engine. Now when they sell an aircraft engine to an airline like Emirates for close to $1 million, right, what are they selling? They're selling this piece of physical equipment, but more importantly, they're selling a servicing contract, right? They're stapling a service contract, maybe for 20 years, onto this engine. So for General Electric, what's their number one cost? What's the number one cost for them? It's engine maintenance, right? Engine maintenance, because they're basically guaranteeing the functionality of this engine for the next 20 years in exchange for periodic payments. So if you can somehow reduce your maintenance costs, then you can increase the bottom line. So what they would do is they would send their mechanics out to take a look at these aircraft engines, every 6 weeks or so, in the same way that you take your car in to have the oil changed, every 6,000 miles or whatever. Okay, now the problem is half the time they would get out there and they would discover that the engine was perfectly fine, right? It didn't really need anything. And so then they would have to reschedule a visit maybe 2 weeks later. Now half the time they would send somebody out to take a look at the engine and they would see that the engine had completely degraded. Okay, there had been all sorts of problems. The rotors were falling off the hinges and you had to go in and completely rebuild the engine. Now both of those are suboptimal solutions. You really want to go out there at exactly the right time, right? The sweet spot for engine maintenance that balances the cost of sending people out there and the benefit of perpetuating the life of the engine. So how can you do that? Okay, if all you have is kind of a mean and a standard deviation based on historical data, I mean, that's pretty good. You can optimize taking into account all those different trade-offs, arriving too early or arriving too late, but what if you could arrive at exactly the right time? What if you could arrive at exactly the right time where the costs are minimized? You could save a ton of money. So how do you do that? How do you know when the right time is if you're General Electric? You can't send someone out every day. So what do? You put sensors in the engine. So there's temperature sensors and pressure sensors distributed throughout this entire engine, conveying real-time information back to GE's servers, right? Back to their cloud. They have a digital twin, right, sitting in these servers. They have millions of servers containing all of the information that's conveyed by these engines, okay? Now, how much data is being generated by these engines? A lot. So every aircraft engine creates 20 terabytes of data every hour that they're in use. Now, if you know anything about data, that's a lot of data. Now, you multiply that by all the different engines out there, okay? It works out to be about 2.5 billion terabytes of data produced by aircraft engines operating inside the continental United States alone. Okay? That's a huge, huge amount of data. That's more data than was created by the human species prior to the year 2000. Okay? So, amazing amount of data. It has to be analyzed, and you can do predictive maintenance based on this data. UPS, of course, uses predictive maintenance on their engines as well. Okay, now that's fine. That's a great story. I mean, I like that story. And if you think about things beyond aircraft engines, if you think about things like oil and gas, which is another industry that GE has been in historically, if you could just save 1% as a result of the analytics that are used on this data, that's going to work out to be about $90 billion in savings from reduced CapEx. Okay, just 1%. And it's very easy to squeeze 1% of savings out when you go from a world where you're guessing to a world when you know, because you have accurate, real-time data. Okay, that's kind of cool, and I like it, and if you're an operations geek, it's awesome. But this story gets even more interesting because the operations people started talking to the marketing people. And the marketing people said, wait a second, you know exactly how our customers are using the product? You have a window into, right, what this product is doing at all times? Well, why the heck aren't we incorporating that into how we sell these things and how we price these things? And so what they did is they realized that we can charge our customers not just for the engine, but we can charge based on how they use the engine, and we can start selling analytics right back to the customer so we can advise them on how better to use these engines. And so now, what business is General Electric in? They're no longer selling engines, right? They are selling access to an engine. They're selling the usage of the engine. Now look, the construction business, what do? You know, you build stuff, you sell it, okay? Or they buy it, you build it. Either way, you're selling a product. What would it mean for the construction business to be a service business, right? Building as a service. Concrete as a service. I was thinking about that this morning. What the heck would concrete as a service mean? What would it mean to be a service business and not a product business? Okay, to have a relationship with the customer that extended past the point of sale. What would that mean? What would that mean for your business? Okay, a lot of businesses are asking that question right now, right? Transforming their business model from product to service. Okay, and if you look at the cost of a building, right? I mean, the construction is actually a relatively small piece of the total cost of the business. And who provides the construction? That's one set of producers. And who provides all the rest? A completely different set of producers. Okay, what if you could integrate that so that the entire life cycle, right, the entire life cycle of the building was actually provided by a single service provider? Okay, what would that look like for the business? But it's not just that, because if you take all this actually amounts to a very, very small piece of what it costs to actually own a building. And you think about like an office building. I'm not thinking about sort of a dam or a bridge. But if you think about an office building, right, the construction is actually a relatively small piece. And this is why people who are commissioning buildings, at least in the office space or in the retail space or the commercial space, right, they're taking a deep interest in the entire life cycle cost of that building. And they want to know how you can connect the cost of construction with the cost of operating, where the cost of operating is operating the people, operating the things that actually use the building. Right? What would it mean if now that you have a window into how the building is being used and how the construction is being used, you could offer, right, an optimization across that entire life as a service, because you are you're the ones that have in the position to access this data, because you've implanted sensors all throughout that building. What would it mean to have a building that is a sensing, living, breathing thing, which can be optimized over time? The usage of this thing can be optimized over the time. The costs of this thing can be optimized over time, because it is a sensing, living, breathing, adapting thing with analytics in the cloud sitting right behind that piece of physical constructed environment. So this is why Mark Andreessen, sort of the famous guy and venture capitalist in Silicon Valley, says, software is eating the world. Okay? Is your business a software business? I mean, concrete's about as hard as it gets. Nothing harder than that, to think of hard constructed products as software. What would that mean? What would it mean for the majority of the value add that you provide to your customer to come from something other than the physical aspect of what you're building? What would it mean for the majority of the bulk of the value add that you sell to come from what is embedded in that constructed environment, right? For it to be something like software, okay? Think about that, okay? What about a company like Tesla? What kind of company is Tesla? Go on. Software company, yes. Okay, I thought somebody was going to say technology company. I thought you got that, you know. But it's a software company. Okay, they make beautiful cars, absolutely beautiful cars, but the bulk of the value doesn't come from the physical product. It comes from the software that runs this thing, the software that optimizes its usage, the software which will ultimately allow you to sit back, relax, and drink a coffee while your car takes you to wherever you need to go. And they're about 95% of the way there, because of all the data that they capture with all the sensors that are distributed throughout that car. Now, what happens when Tesla introduces a new feature or a new aspect to the car? Now, in the old days, if you wanted to get a new car with a new feature, right, you wanted to get power steering or power brakes or anti-lock brakes or some new thing, you had to go and buy the new car. So Ford would announce, hey, great new feature, we got a camera in the back so you don't run over your kids. You know, you're like, that's awesome, I don't have that. What do you have to do? You have to go down to the dealer and buy the next generation of car. What if Tesla says, we're introducing a new feature that allows you to parallel park your car with the push of a button? What do? Do you have to go get the new Tesla? No. You just upgrade the software. What would it mean for someone to improve their constructed environment, not by calling back in the construction crew, not by calling back in, right, the people to scurry around and start adding stuff physically, but what would it mean for you to be able to improve the constructed environment with the push of a button? Because the features that were embedded in that physical environment were actually software-based primarily. What would that mean? Okay? What would that mean for your business? These cars have sensors everywhere, and they have little processors everywhere, which help them to operate in an optimal way. Now, I talked about Walmart, and I kind of left a story halfway, because Walmart, what makes Walmart so interesting is not that they have this amazing logistics system internally that communicates information from the point of sale all the way back to the point of purchase. What makes it interesting is that that information gets communicated back to their suppliers, so that when you buy something at Walmart, the information goes back to the purchasers, but it also goes back to the CPG manufacturers. So when I buy a box of diapers, okay, that goes back to the loading dock. It goes back to the purchasers. It goes back to Procter & Gamble, and Procter & Gamble can put a box of diapers on their loading dock seconds after I purchase it in the Walmart thousands of miles away. Okay, how do they do that? They do it because Walmart's computers talk to Procter & Gamble's computers. Okay, they call this EDI. Okay, EDI. Right? Computers talking to computers, companies talking to companies in real time. And that's because what you have throughout the supply chain is something called a modular system. What's a modular system? This is a modular system. Does anybody remember having a stereo like this? You look way too young, my friend, to have a stereo that looks anything like this. Your father, okay, yeah, your father, your grandfather, okay. I had one of these things when I was young, and I was super proud of it, you know, and the sound was fantastic. You look like you had one of these things, too? Yeah, you still have it, okay. All right, I don't know where, okay, you know, you still have it. You still have the turntable on top?
Yes, I do.
Wow, okay, super old school, okay? So I had one of these. My father loved it so much. He came into my room, he heard it. He said, this is awesome. So he went out and bought one for himself. Okay, is yours like the one on the left or the one on the right?
It's like the right one, and I actually bought it off my dad.
Yeah, okay.
I bought it up because I know it's yours.
So look, this one is not the same. You notice the one on the left is fake. It's like the stripes on the chicken in the Arab grill over here. They're painted on. Wasn't actually cooked on the open fire. And actually here it was, I think. Okay, it's fake, right? These are fake stripes here. So which is better? Which is better? Which is a better system? Okay, so you said the modular one. You guys think the modular one's better? Well, the modular one certainly has features. If this thing was so good, then you wouldn't see anybody making the one on the left. There must be something attractive about the one on the left. There must be something attractive about this vertical system as opposed to what we see the horizontal system over here. There are industries that are organized like this, and there are industries that are organized like that. So on the left, right, you can get economies of scale. It's a one-stop purchase. You go in there, you buy it, click, you're done. Over here, you have to assemble it yourself. So look, the one on the left has certain advantages. One advantage is that you can have a much wider range of potential final products. Right? So over here, if we had 4 manufacturers, and they all made these things we call appliances on the left, you only have 4 things that you could order. If everybody's operating on the left-hand side, and the right-hand side principle, you have 4 manufacturers, each making 4 different components. How many different possible combinations of stereos can you have? 4 times 4 times 4 times 4. 4 times 4 times 4 times 4, that's 256. Yeah, 256 different possible combinations, right? And so that allows for much greater variety. And we call that sort of a network effect. Okay, a lot more variety. Okay, the other thing that's good about this is that it's fault tolerant. If one component breaks, you don't have to then go and replace the entire thing. You just replace the part that's broken. And what's the most common form of breakage? Obsolescence. So if your turntable is obsolete, you replace it with a tape deck, and you replace that with a CD player, and you replace that with your phone, and keep all the rest the same. Okay? So this modular system has some wonderful advantages. The one on the left has economies of scale, and it's simpler to deal with. So, you know, the old Apple, software and hardware integrated. Over here, right, they're not integrated. And so our phones today are like the thing on the right. There are not 256 different possible combinations. There are more combinations than there are atoms in the universe. In fact, I'm willing to argue that every single person in this room has a different phone. How can we all have different phones? Because what is the phone? The phone is the unique combination of apps that you have on your phone. That's what the phone is. The physical piece of the phone is only a small part of it. It's really the constellation of apps that you have. And nobody here has the same 2 compilations of apps, I'm willing to bet. Okay? So what makes this thing on the right possible? What makes it possible are these standardized interfaces. So you can pull one component out and pull another component in. Okay? And that's easier said than done. So in the United States, back in the day, we used to have railroads emanating from Washington, D.C. over here and Chicago over there. And as they got closer and closer together, and they met in the middle, they realized they had a problem. You know what the problem was? The gauges didn't meet up. Okay, so we got some construction engineers here. You probably, if you ever drilled a tunnel under some territory, you know, coming in 2 different directions, and you're like, uh-oh. Did that ever happen to you? Don't admit it, if it did, but it's bound to happen. here you have these two gauges that are different, and so you can't actually travel from one place to the next without taking the train off the tracks and onto another track. Okay? If you don't have the same gauge, then you can't travel between two different destinations. And in Europe, we have this problem, of course. You can't travel from Moscow to Lisbon without changing trains. You know, we all have this experience when we travel, right, where if you take a power cord from one city to another, you need some kind of adapter in order to make it work. And I've discovered that here in UAE, right? I've got the UK adapter. So these interfaces have to be standardized if you want to have a fluid movement of products across country borders, and if you want to have a fluid movement of trains across borders. Okay, so what is the modern day equivalent here of standardized interfaces, like the ones that Walmart has with Procter & Gamble? Well, what we do, we call them APIs. Okay, how many of you heard the term API? If you're in the software business, this is a term that everybody knows because it's essentially the interface between two pieces of software. Okay? So whenever you go on your phone, and you know, I use Kayak a lot to buy airline tickets. When I go on my phone and I hit up the Kayak app, what happens is that Kayak actually sends a message out to all of these other providers of travel services, and these computers start talking to one another. The message goes out, message comes back, okay? And ultimately what happens while this thing is spinning, there's a lot of back talk, and then ultimately your results pop up on your phone, right? This happens without you really even thinking about it. But what's happening on the back end is that all of these computers are talking to each other. So the Kayak's computers are talking to the Apollo computers. They're talking to the United computers. And how can they do that? So because they all speak the same language. So ultimately when I get inside the United app, right, I can buy my ticket, and I'm actually communicating with United servers directly in the cloud, with each of these buttons corresponding to a unique set of code that's sitting on United's servers. But here's what makes it really interesting, if you think back to that Walmart example. Suppose that I'm United, and I'm like, man, Emirates has that whole thing with the limos. That's so cool. Maybe we want to give our customers the ability to get a limo to the airport. Now, do you have to hire limo employees? Do you have to buy limos? No, all you have to do is embed the Uber app inside the United app. Right? You don't have to get into the limo business yourself. You let them get into the limo business, and then you create an interface so that you just cut and paste the Uber app into the United app. And all of this is happening on the back end because it's the software developers that are doing it. Okay? And that's because United's computers can talk to Uber's computers because they know the language, they know the code, they know the key. All right? Now, once you're inside Uber, you got a map. Now, did Uber build out these maps? Do they have mapping technologists on staff? No. All they have to do is embed the Google Maps. Okay? And that's because they have access to the key. They have access to the code. They know how to cut and paste the right code into their app. So Uber's apps are talking to Google's apps. And then when you finally pay, does Uber have to get into the payments business? Do they have to create a payment app? No. You use PayPal or some other app. Okay? And that's because their computers can talk to their computers. So all these computers are talking back and forth, and it's all because of the magic of what we call APIs. So this is what I say. APIs are eating the world. Right? APIs are eating the world. Or modularity is eating the world. Okay? Now all those companies I was talking about, like UPS, right? And Walmart, you know, they have this comprehensive system where everything happens in-house, doesn't require, right, this external communication. But the thing about modularity is that you can move things across all these different corporate boundaries and all these different modes, like modes of transport. So the invention of the box completely transformed transportation and logistics. Because now, once you have this box, you can have the automated container ports. This is Rotterdam, right? You heard about Rotterdam. All of that stuff in Rotterdam is run by computers and robots. There's no humans there deciding where to put the boxes and where to unload and when to unload and where to transport. It's all done by computers because the human brain is incapable of processing that much information. And so now we can track our ships no matter where they are in the world, right? We can see how fast they're moving. We can see their location, their speed, right? Everything. It's all trackable in real time on your phone. And then not only the ships, but the containers, because you can have on the containers, right, some kind of mechanism for transmitting its information, its location. So this is like a container of fish, and you can see it in real time. You can see its location. You can also see the temperature of the fish container at all times. You can see whether the door was sealed. Okay, all of this is captured through IoT and telematics. And so anybody who's in the logistics business, it's super cool. You can be sitting on your phone and just see where everything is in real time. Now, what does that mean? That means that you don't need to have a single company that handles the entire business from the point of pickup to the point of drop-off like a UPS. Instead, you can, like with a modular system, break down this production process so some people can specialize, right, in the financing. Some people can specialize in the documentation. Others can specialize in the movement of goods and services. And as long as they can communicate with each other through APIs, you can take advantage of these different specialized skills. So this is one of my favorite companies. It's called Flexport, okay? It's based out of San Francisco. It's now becoming the world's largest logistics company. And they don't own a single boat. They don't own a single truck. They don't own a single piece of physical equipment other than the computers in their offices, right? How are they able to do this? Because of APIs, because of Internet of Things, because all of these computers can talk to all of these other computers, okay? Now, General Electric, they can tell you how to use the engines, but what about the planes, right? Wouldn't it be nice to know how to operate the planes? Now, in order to do this, they have to be able to communicate with Boeing's computers, because Boeing is capturing all the data that's happening on the rest of the plane, okay? Because you want to integrate all of the activities across all of these planes. What about all the planes in your entire fleet? You want to be able to communicate all the information from all of the planes on the entire fleet, and so on, all the way up to all of the planes in all of the skies everywhere in the world. Right? We have cars that can do amazing things. At some point, they're going to be communicating with each other, and they're going to be communicating with the road, and they're going to be communicating with the buildings. Soon the buildings will be talking to the other buildings, right? And then you're getting information not just from your building, but from the other buildings. I read a fascinating book about how trees communicate with other trees. Maybe you don't know that, but they actually send out signals so that one tree is attacked by parasites. It sends out a message to the other trees in the neighborhood so that they can arm themselves to defend themselves against the parasites. Right now, do buildings talk to other buildings? Well, soon they will. When we talk about connected buildings, it's not just you being connected to the building that you own or the building that you constructed, but it will be buildings talking to other buildings. So how can they do this? It's going to have to be through APIs. So FedEx, end-to-end shipment company, it's being broken up because every single feature is going to be attacked by some specialist. And as long as those specialists can talk to one another through APIs, you can reconstitute a FedEx with best of breed. Okay? Think about a phone and how it's manufactured. Apple, what does Apple make? Nothing. Well, they make the software, okay? But the actual phone, nothing. We've got Corning, we've got Samsung, we've got Foxconn, Qualcomm, we've got all these other companies that can provide the parts and they throw it all together. And they don't even throw it all together, they have someone else throw it all together, okay? And these people are coordinating and cooperating from all around the world, okay, because their computers talk to each other. Think about the assembly of a phone, right, of a plane, all of these different companies all around the world. What an incredibly sophisticated logistical process these guys have. Okay? When you're building an app, same thing. You just cut and staple a bunch of different pieces of software. You don't have to do anything yourself because of APIs. If you look at business models like Amazon, Amazon doesn't have to do everything. In fact, most of the stuff they sell, they don't even sell from their own warehouses. I mean, they sell from their own fulfillment centers, but they come from other people, okay? Because they can interface with other providers through APIs. And so the modern business is now, right, just a compilation of individual functions that are provided, maybe some in-house, maybe some externally provided, and as long as they have APIs around them, they can be stapled together at will. And so business model evolution is just tearing apart the Legos and reconstituting them in new shapes. It becomes so much easier to evolve as a business when you are organized this way. So think about the construction supply chain. Think about how complex this can be. right? And think of all the different players and all the different actors involved. How do they communicate with each other? Excel spreadsheets, right, going back and forth, and documentation flowing back and forth, and images, right, and CAD files all flowing back and forth, okay? This communication is sometimes fraught with difficulty. It's fraught with complication, okay? Architecture, for instance, is not about building buildings. It's about creating documents. And every single construction project that's ever happened since Ur and since Mesopotamia has had a lawsuit attached because of some kind of miscommunication, right? Because of some kind of error, because of some people speaking different languages. What if everybody was speaking the same language? And what if this was organized around APIs so that you could continue to break apart and put back together the construction management process, right? What would that be like? So that you could leverage best of breed at the same time, maximize efficiency through data. So a lot of exciting things are happening in the world of what I call smart contracts. Smart contracts are self-executing contractual agreements with parties involved in a complex building project, okay? This can minimize lawsuits, reduce complications, because as soon as something gets executed, the payment is released, okay? How can this be possible? Because of sensors, because everything that happens is tracked in real time and captured through sensors. So perhaps you don't know this, but Tesla has this feature where, you know, if you go for the cheap Tesla, you have low performance, and you go for the expensive Tesla, you have expensive performance. What's the difference in the car? Nothing. It's the same car. It's just a switch that they flip on or flip off remotely. So when they had this big hurricane in Florida, they just sent out an upgrade to everybody, right, through the internet, and they're all of a sudden their cars had a couple 100 miles, they had 100 miles extra distance that they could run, okay? So what would it mean for you to be able to upgrade things? What would it be like for you to write contracts that were self-executing? So construction litigation was reduced and eliminated. So this is something that I read recently in a McKinsey report, which said that of all the industries out there, guess which industry is the second least digitized in the world? Construction. There's only one industry which is less digitized than construction. You know what it is? Hunting. Hunting. Now think about that. You guys have beat hunting. Give yourself a round of applause for beating hunting. Okay? Wow, that's great. Hunting is less digital. But guess what? Hunting is catching up to you. There are people that can hunt from their bedrooms with remote-operated guns. Have you seen this? So you can actually, in your basement, hunt prairie dogs in Nebraska from anywhere in the world. They're catching up to you, and they're going to surpass you. Agriculture has already surpassed you. Monsanto now has 75% of the arable land in the United States digitized, and every single piece of farm equipment communicates through their FarmView platform, okay? Agriculture has already passed construction, and the only thing left is hunting. Think about that. So what would it be like for your industry to be a software industry? What would it be like for your industry to be a service industry, a technology industry, right? One where the majority of the value came from things other than the physical constructed environment, okay? What would it be like if you had access to information that answered every single question that you had about your built environment, so that you knew at all times where the corrosion was, for instance, okay? In San Francisco, we had a pipeline that burst a couple of years ago underneath a neighborhood, killed a bunch of people. How is that possible in this world, right? These companies should have access to real-time information about the pressure buildup, and now they've installed sensors throughout the entire network, and so they'll catch these things. I had a friend who bought an electrical utility in Latin America, and he made back his money in 18 months. Everything after that was pure profit. What did he do? The only thing he did is he put sensors throughout the entire network, and he was able to detect where the energy was being lost, where was it leaking, where was it being stolen, and then he could send people out immediately to repair it. The only thing wrong with that model is he had to send people out, okay? Now he shouldn't have to send people out. He you should be able to fix it remotely. Okay, that's the next step. Think about construction like that. So this is what's happening. This is what's driving it. Your phone here, I have an iPhone 7, but if you have an iPhone 5, you have more computing power than the computer that put the man on the moon. Okay? Not just more, but a lot more. It is 1,300 times faster than the computer that put the man on the moon. Right? It has 250,000 times more processing memory, 2 million times more storage, and look at the thing. It's tiny compared to that computer that put the man on the moon. And this is an iPhone 5, this is not even an iPhone 10. And this is the computing power on the phone, not the computing power that you have access to through the cloud, which is billions of times more than what you have on the phone. Okay? The world has changed so dramatically in just the last month, much less the last 10 years. Where's construction in this space? If you wanted to buy I was in business school in 1991. It would have cost me $3.5 million just to buy the computing power on the phone, the iPhone 5. And what does it cost now? Nothing. So, every building, of course, is going to wind up like this, right? Nothing lasts forever. But along the way, we can get a lot more value out of our built environment. A lot more, okay, if we think about it differently, okay? So hopefully I've just given you a few things to think about. Maybe when we come back and have this meeting in 10 years, it'll be very, very different. So thanks. Thanks for having me.